Boys and girls, this is Mr. Minis here again, and I've got another super cool video. This actually is going to be the very last video of the entire geometry curriculum. Yeah, we did it. So this is the last lesson in the probability unit, which is our last unit, so we are going to be officially done. So without further ado, let's go ahead and jump right into the lesson. So the last thing that we're going to learn about in the probability unit is two-way frequency tables or relative frequency tables when we have data in columns and rows, figuring out what the probability of different things are. So it says up here at the top, it says two-way frequency tables display the frequencies of data in two different categories, okay, rows and columns. This first example here, we've got 90 students who were surveyed to find out whether or not they ate breakfast on a particular morning, and the results are below. So they have left parts of this table blank. So the totals are across the bottom, and in the final column there are 90. So we just need to fill in the rest of the chart. So I'll just add those two numbers together, 40 and 12. That's 52. For students that ate breakfast, add those together. That gives me 38. Add across in the row, 40 plus 14, that gives me 54. 12 plus 24, that gives me 36. And we always want to do a quick double check. Does 52 plus 38, does that equal 90? Yes, it does. Vertically, does 54 plus 36, does that equal 90? Yes, it does. Okay. Now, in this lesson, just like any lesson in probability, we got to pay attention to the trigger words and what the problem is asking for. This says how many. Okay, how many is different than what is the probability. Probability is a percentage, a decimal ratio. How many is a hard number. How many students between the ages of 10 and 13 were surveyed? Okay, between 10 and 13. How many, we're looking at this row, how many were surveyed? The total is 54 that were between 10 and 13, so 54 students. How many students between the ages of 14 and 17 said that they skipped breakfast? Okay, so only looking at the students between 14 and 17, only looking at these guys, how many said they skipped breakfast? That's going to be that number right there. 24 of them said they skipped breakfast. Okay, how many students said that they ate breakfast that morning? Okay, how many? That's a hard number. How many ate breakfast? Well, we're looking at this column right here. These are all the people that ate breakfast. The total is that guy right there. So 52 students said they ate breakfast. Okay, those are just kind of hard numbers. And we got a couple of vocabulary words here. Joint. Joint frequencies are entries in the body of the table. That would be these guys right here in the middle. Marginal. Marginal frequencies are shown in the row and column totals. So these will be marginal, these will be marginal. What does the word margin mean in regards to paper? It means on the edge, right? On the edge of the paper. Okay, so those are our totals on the edge. When a two-way table displays percentages or ratios, these are going to be called relative frequencies. Okay, relative frequencies. When a two-way table displays these relative frequencies instead of frequency counts, and instead of hard number, the table is referred to as a two-way relative frequency table. Okay. Now, oh, sorry. Okay, I'm so sorry. Y'all couldn't see that. I apologize. Joint, marginal. Okay. When we have percentages in the chart instead of hard numbers, these are hard numbers. When I have decimals, 0.3, 48%, these are going to be called two-way relative frequency tables. Okay. So how do I actually create this? I'm going to take all these numbers and turn them into percentages. So how do I find the percentage of students between 10 and 13 that ate breakfast? I'm going to take that number and divide it by the total number of people we're talking about. So 40 divided by 90, that simplifies to 4/9, okay? Or I'm going to write that, if you type that in your calculator, 4 divided by 9, that comes out to be 0.44. So again, it says it can be a ratio, a decimal, or a percent. Okay, I could write 44% if I wanted to. And I'm just going to do that for each number. 14 divided by 90. That comes out to be 0.16. 12 divided by 90. That comes out to be 0.13. 54 divided by 90. That comes out to be 0.6. I'm not going to spend any time in this video going through each one. I'm just going to give you guys the numbers. You can verify these on your calculator. 0.4. 0.57, 0.43, and then what is the total down here as far as percentages? This will be 1 or 100%, right? Or 90 out of 90, Okay, so all these percentages, all these decimals have to add up to 1 or 100%. Okay. All right, so let's answer some questions down here. So number 1 says, what percentage of students skip breakfast in the morning? Okay, these are all the people that skip breakfast, right? So we're looking at the total. So the total, but remember this is what percentage. We're not looking at a hard number. The percentage is 43%. So you could write 0.43 or 43% of the population said that they skipped breakfast that morning. Okay. All right, let's go on to the next page here. Okay, what is the relative frequency of students between the ages of 14 and 17 who ate breakfast? Okay, so if we go back again, go back to our chart. Okay, relative frequency between the ages of 14 and 17 who ate breakfast. Okay, so we're only looking at the 14 to 17 people. What percentage of them ate breakfast? That's going to be right here. That's going to be these people right here, the 13%. Okay, so going back up here, 0.13 or 13%. Okay, conditional probability and frequency tables. Okay, so what we just looked at was two-way frequency tables. Now we're going to look at conditional, which is going to piggyback off of yesterday's lesson. And the most important word from yesterday's lesson with conditional probability was the word given. What is the probability of something happening given that something else has already happened? Okay, so we're going to be looking for that word here again as well. Okay, so what I want you guys to write in your notes, this is critical right here. Right in here somewhere, I want you to write, put a little asterisk, I want you to write in your notes, whatever comes after the word given or the word perhaps who tells you whether you are looking at rows or columns. This lesson, guys, has historically been pretty tricky because students will get confused whether or not they're looking at horizontal rows or they're looking at vertical columns. Okay, and this is your trick that I'm giving you right here. Whatever comes after the word given or who will tell you whether or not I'm looking at data in a column or I'm only looking at data in a row, horizontal versus vertical. Okay, now once again we got some missing values here, so obviously to find this you would just take 780 and subtract those numbers, that gives you 200. Take 120, subtract those numbers, that gives you 20. This is 40. Add those numbers across, this becomes 380. Add those numbers across, this becomes 210. And then of course you could add these up vertically and horizontally and make sure they add up to 1,000. But I'm not going to spend a lot of time on that. Okay, number 1 says, what is the probability of someone being for the bill? Okay, is this conditional probability? You see the word given? Do you see the word who? No, you don't. Okay, so this is not conditional probability. They just want to straight up know. This is just like we did on the previous page. Okay, you know, what is the probability or what is the percentage of something happening? Okay, so we don't have a predefined assumption. We don't have a condition. Okay, what is the probability of someone being for the bill? Okay, so we're looking at all the people that are for the bill. That total, we've got 780 people. Okay, I guess maybe I should have read the problem. Sorry. Respondents of a poll were asked whether they were for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. Fill in the rest of the chart and answer the question. So these are people that are for a minimum wage increase, against it, or they just don't care. Okay. This first problem is saying, what is the probability that someone likes it? They want a minimum wage increase, maybe for their kids or whatever. They like that idea. That's 780 people that like it out of how many? Out of 1,000. So that's just a straight up percentage. 780 out of 1,000 people say, yep, I like it. That reduces to 39/50 or 78%. I kind of like to do percentages on stuff like this. It gives more bite, more meaning to it. If you say 80% or 4, I can say, okay, I got you. That's about 4 out of 5 people. The next one, what is the relative frequency? Okay, now what does that mean? Again, that's just a fancy word for what? That's a fancy phrase for probability. Relative frequency, how often is it occurring? 0.2%, 0.2, 43%, 9 out of 10 times. It's just another way to say probability. So this is basically saying, what is the probability of someone against the bill between the ages of 30 and 45? Okay. Now, once again, is that a conditional probability? Do you see the word given? Do you see the word who? Okay, no, we don't. Okay, so this again is just a straight up probability. What is the relative frequency of someone against the bill between 30 and 45? So that's these people right here. So between the ages of 30 and 45, 30 people were against the bill. That's 30 people out of how many total people? What percentage is for, but also in this age bracket? That's 30 people out of the total of 1,000 people. That is only 0.03, or that's only 3% of the entire population. Only 3% of the people are against the bill and between the ages of 30 and 45 years old. Okay, not very many people. That's a small chunk. Okay. All right, number 3 says, what is the probability that a randomly selected person is over 60 years old? What's that word? Boom. There's that word. Given. Okay. What is the probability? So this is going to be a percentage, a decimal ratio. What is the probability the person is over 60 years old given that the person had no opinion on the bill? Okay, so I'm going to use cards again. So now when I see the word given, when I see the word who, when we get down here and we see this little vertical bar, this is also conditional probability from yesterday's lesson. Then I'm going to go back to the trick that I taught you guys. Whatever comes after given tells you whether or not you're looking at a row or a column. What comes after given? Given that a person had no opinion. Okay, now no opinion, is that a column or is that a row? Okay, that is a column. So in your notes, right here, I want you to draw a little arrow. I want you to write column. We only care, I'm going to use cards here, we only care about this column. Okay, we don't care about any of these numbers. I could scratch out all that, all the against, all the for. We don't care about any of those. Given that we're only polling, we only care about the no opinion people, what is the probability, okay, that they're over 60 years old? Okay, in this column, we have 40 people that are over 60 years old, but we only care about these 100 people. The condition is we're only looking at the no opinions. So it's going to be 40 out of those 100 people are over 60. Okay, now if I want to write this in the correct notation, I would say probability that we're over 60, and then here's that vertical bar from yesterday's lesson, under the condition that they don't have an opinion. Okay, and that is going to be those 40 people out of the 100 total non-opinion people. Sorry, out of 100. That's 4 out of 10 or 40%, 2 out of 5. 2/5, I guess, if we reduce our fraction. Okay. Number 4, what is the probability, so a percentage, decimal, that a randomly selected person is 30 to 45 years old, bam, given that the person is in favor of the bill. They're for it. Okay, given. Whatever comes after the word given tells you whether it's a column or a row. Okay, given that they're in favor. Okay, let's go up here. They're for it. Is that a column or a row? Okay, that is a column. So I don't care about any other columns. I'm only looking at the for column. I only care about these 780 people that were for it. Out of those 780 people, what's the probability that they are 30 to 45 years old? Okay, that's going to be these people. Okay, that's going to be 200 out of the total of 780 people that were for it. Okay, so I would write this as probability that they are 30 to 45 years old on the assumption given that they are for the bill. Okay, once again, that's going to be these 200 people out of the 780. Okay, I believe that reduces to 10 over 39 or 25.6%. Okay, so roughly about a fourth of the people. A fourth of the for the bill people are in that age bracket. Okay. Number 5, what is the probability that, again, probability, not a hard number. What is the probability that a randomly selected person is for the bill given that the person is not between the ages of 46 and 60? Okay, whatever comes after given tells you row or column. So we're talking about not in the age bracket. Okay, so if we're talking about ages, is that a row or a column? Okay, 46 to 60, that is a row. Okay, that is a row. Now normally, now this is a kind of a tricky problem. It's probably one of the hardest problems on the whole lesson. Normally I would say, okay, so we don't care about any of the other rows. Okay, we only care about these people in the age bracket. We only care about these 120, 20, 30, the total of 170. We only care about this age bracket. But here's what makes this interesting. It says, given that the person is not between the ages of 46 and 60. Okay, so this one's kind of weird. So now this is kind of like the complement with those Venn diagrams where it gets kind of confusing when we're going backwards. Now, the only ones I don't care about are the ones, see if I can use a pen here. Now I don't care about the 46 to 60 people because it says given that the person is not in that age bracket. Okay, so I'm going to cover up all these. So now what I care about is everybody in these rows except for those people. Okay, now here's where it gets tricky. What is the total of the people that are not 46 to 60? The total is the 380 plus the 420, the 380 plus the 240, I'm dyslexic, plus the 210. We're not looking at these totals here. I only care about the 18 to 29 people, the 30 to 45 people, and the over 60 people. Those are all the people that are not the 46 to 60. Okay, so once again, that's going to be the 380 plus 240 plus 210. That's what goes on the bottom. Okay, so let me go back down here. So this is going to be probability that they're for the bill under the condition that they are not in the age bracket of 46 to 60. Okay, and now the bottom we already said is out of 380 plus 240 plus 210. That comes out to be 830. Okay, 830 people are not in that age bracket. Now, out of those people, what is the likelihood that they are for the bill? Okay, now how many people are for the bill out of all these rows? The people that are for it are the 310 plus the 200 plus the 150. Okay, so we got to add 310 plus 200 plus 150. That comes out to be 660. That reduces to 66 out of 83, which is about 79.5%. That is a tough one, guys. Make sure y'all can see that. That, no doubt about it. That's a toughie. So again, if you need to pause the video to go back and kind of understand that one, I wouldn't blame you. Pretty confusing it can be. All right, number 6. All right, now we don't have a word problem here. We don't have the words given. We don't have the words who, but we do have this bar. So remember from yesterday's lesson, whatever comes after the bar is your given. So what is the probability that we have no opinion under the assumption that they were in the age of 30 to 45? Okay. So is this a column or a row? 30 to 45. That is a row. Okay, so draw a little arrow and put row. I forgot to go back to these, by the way. Given that this person was in favor of the bill, this was a column. And then the confusing one that we just did, this was a row. This one that we're doing, this is a row. We only care about these people in this row. Okay, so we only care about these 240. Use my cards again. We only care about this row, these 240 people. Okay, so the probability that they have no opinion based on these 240 people, here's the no opinion. 10 of these people, 10 of the 240 who are in this age bracket had no opinion. Okay, so that's going to be 10 out of 240, which comes out to be 1 out of 24. 10 out of 200 is 1 out of 24. Okay, next one says, what is the probability that we are in this age bracket given under the assumption that we are for the bill? Okay, whatever comes second, whatever comes after given, all right, is your row or column. For the bill is a column. Okay, so I don't care about any of these other columns. Okay, so we're looking at these people. Out of 780 people, what was the percentage that they are in that age bracket, 46 to 60? That's going to be these people. 120 in this age bracket, 120 out of the total of 780. 120 out of 780. That comes out to be about 2 out of 13, or 15.4%. Okay. What was this one? The given, what is that? This one was a column this time. Okay, so if you guys don't remember anything else that I say in this video, you got to remember that. Whatever comes after the word given, sometimes you'll see the word who. You know, what percentage of people were for the bill who were in the age bracket of 30 to 45, something like that. If you all you see is the bar, whichever one comes second, that's your given. That will tell you whether or not you're looking at a row or a column. Okay. Unfortunately, guys, I am going to need to stop there, so this video is not too long. I know there's a little bit more. I'm sorry, I didn't really get to finish this lesson. But anyway, if you guys want to try these last 5 here, just kind of optional. If you want to do these, you can, and check your answers online. Or if you guys just want to go ahead and start on your day 6 homework. All right, that's it for this video, and we will see you on, I would say we'll see you on the next one, but that is the very end of the geometry curriculum. So congratulations, pat on the back. You did it. Love you guys.